Hello and welcome to Lands Unknown. My name is Will, and today we are going to continue with the close climate study of the Tyche Basin. All right, here we go. Just making sure I got everything up. Please let me know about the audio and how that is going. I should have figured out everything from last time. Hey, Jake. Hi, Kate. There. That's nice. It should tell me in the top corner. I'm going to switch this a little bit. NDB should tell me what I am streaming on. Whatever. Oak Ridge is here. Oak Forest is here. Lots of familiar faces. Like Jake was saying last week, just like a religion now. We even worship the sun. So, what we are looking at here is all of our landforms. Last week I introduced my little geographical geological notes that I'd made. And I had to go back to my notes, actually, to see all of the stuff that happened in order to create this system here. Where are we? Yeah, so let's just throw another layer on here. So, that is not a very large brush. That's not very helpful at all. The other suns are false gods. Yes, we only have Mr. Smiley Face Sun. Their suns are false gods. It snowed where you live. Oh, that's wonderful. It has not snowed here yet. I thought it could snow last week, but it did not. Instead, it is very nice and sunny. As we can see, because I have a south-facing window here. And all that light just streams in. Maybe not the best idea for setting up a studio situation, but, that's what we got. So this MOR along here opened as this was being, pulled towards yes, as this was being pulled towards here, I believe it closed because the slab pull along here stopped for a period of time after some collisions. And after it stopped, this ridge sort of flooded with magma. So that MOR closed. Then when this subduction started again, this rift started to happen. And I mean, here it's about 150 kilometers, probably about 200 or 300 kilometers, 50 over there. But this rift didn't fully break off, and it was only after the collision of Arukia down here that we actually had, and Polomia as well, where we had some fracture break off here. So this rift here is a lot like Madagascar, where we have like a failed microcontinent that has some ocean crust between it and Africa, but usually some other tectonic event that's going on stops it from breaking off. So one of the things as well we talked about was this island chain that separates the Agathe from Tyche. And so this was not always largely a transform fault. When this was dormant, it actually became a subduction zone. It was only after, these collisions that are happening that it kind of, changed around. So we do have like a brief tectonic sketch there. Oh. Oh, you're in Florida. Oh, wow. Okay. Yeah, it must be like that time in Texas when it's. But I believe because Texas has its own inefficient power grid, everything collapsed. Oh, it snowed all day yesterday. That's wonderful. What are my Ice Age homies? Oh, just just being glacial. Glacial Sunday mornings with Mr. Sun. Okay. So now we are going to be working through the climates. I'm going to start by doing the central terrains. And oh yeah, we don't need me in here anymore. And everyone can still hear me. I did not remove myself. So we're going to mainly work on these interior terrains today because I think one thing they're the most interesting, but they're also one of the easier ones to do. Horizon to-do list 2012. You can still hear me. Brilliant. That was an issue that happened last time. I'm learning. Nature's learning. So, and because of where the winds are coming off, we have. Oh, what is going on? There we go. So, because in the summer we've got a high pressure zone over the region, so we're going to have minimal precipitation over these terrains, or at least the majority of the terrains in the northeast. We're going to see some, more significant precipitation. But in the interiors, we're not going to see very much. In the interior of the sea, we're not going to see that much. However, in the winter, like here, we're going to see a decent amount of precipitation. And it's all going to be coming from, a majority of it's going to be coming from the northern part of the basin. We are also going to get some precipitation to the western side of the rains from the from westerly winds from the Agathie, which will be nice. If you'd watch the footnote video, don't need that. So if you'd been watching the footnote video, I went over the different thresholds that we have for distinguishing B and arid B climates from humid A, C, and D climates. So I'm going to share something else on my screen very quickly. Allow. All right, now that I'm sharing, I need to move that from stage, add this to stage. Cool. So, I can be here for this. All right, so in what this chart demonstrates is at what threshold at what minimum threshold for annual temperature and annual precipitation we have where a humid climate transitions to an arid climate. So if we get, and you can see my cursor, yeah, you can, great. So if you get 600 millimeters of annual precipitation and your average annual temperature is 18 degrees, that's going to be a humid climate if you're receiving even precipitation throughout the year. If you receive most of your precipitation during the summer, and the summer here is the 6 months of the year where you receive the most insolation, which is between April and September, then if you have 618, you could be in a BSH or BSK situation, depending on how close to 600 millimeters you are. And this is because during the summer, you're going to have more evaporation and more transpiration. Meanwhile, in the winter, and please excuse that these ones are crunched in. I made it very quickly this morning. Otherwise, I would have changed the font size for all of it. If you receive 600 millimeters at 18, you are well in the humid zone. So this is why we can see climates in regions that would otherwise be a BS climate. So if we're thinking about, let's say, like Cyprus, for example, on the south and north coasts of Cyprus, they receive like 550 millimeters of rain. In the mountain range, there's a big mountain range. I think the tallest peak is Mount Olympus. I think there are a couple of Mount Olympuses in Greece, but the Mount Olympus on Cyprus receives over 1,000 millimeters of precipitation, and it's a CSB climate because, of course, as we've talked about before, cooler cold air masses hold less moisture than warm air masses, so condensation occurs and precipitation happens. So one of the reasons why some of these hotter areas don't receive as much precipitation, especially when they're in those high pressure bands, usually is due to how warm they are. So if you have 550 millimeters of precipitation and your average, annual temperature is 21 degrees, oh, there you go. You're fine. You're very much a CS climate. CSA, most likely. If you're receiving an even amount of precipitation throughout the year, you have that 55 and you have that 21, you're a BSH climate. And you are certainly a BSH climate if you receive most of your precipitation in the summer. And the reason why these are different is because if you receive most of your precipitation in the winter when it's cooler, there's less evapotranspiration happening, more water can seep into the ground, and you can have wetter soils. And a lot of the plants that grow in Mediterranean climates, there's some that are evergreen that can just, use water throughout the year to grow. And they may grow through the winter. In most cases, winter isn't much of a growing season. But for deciduous plants, they can store a lot of water and then use later. Or they can just tap into just the wet soils and the groundwater that they have. So that's going to be the difference, right? So that's why we can see these like Mediterranean climates in regions that are pretty arid. It's because the way that their hydrology interacts with the atmosphere, so the hydrosphere interacts with the atmosphere, is different than the others due to when the majority of precipitation is being received. The other thing to keep in mind too with the CS climates is in order to be a CS climate, winter needs to receive at least the wettest winter month needs to receive at least 3 times the amount of precipitation as the driest summer month, and the driest summer month can't have more than 40 millimeters of precipitation. So there are some CFA climates, like in, I don't know, or in some CFB climates, I suppose, in like northern Spain, like in the Basque region, or western France, for example, that still receive of the vast majority of their precipitation in the winter. It just, in the summer, the driest summer month receives more than 40 millimeters. So there are places that we could broadly categorize as Mediterranean that in like, in a spiritual sense, even though they don't fall into that category for Köppen. Because again, Köppen is trying to do very specific things and trying to describe certain relationships between temperature, precipitation, and the kind of vegetation that he saw in 19th century, on 19th century Earth, which, correspond closer to pre-industrial average temperatures and CO2 and those sorts of things. All right, so now I'm going to stop sharing that and add that to stage, and we can switch back to the map. Beautiful. All right. So now I'm going to create the layer everybody has been waiting for. Rename CSB. Not can. This is inappropriate. CSB. And that creates a little space behind it. Whatever. We're gonna have to deal with that. So I do want. I can go up there, and that can go up there. Because I do want this should be its own layer, not below that. Great. Also, for those of you who were in here last time, you can see. Oh, hello, Not Daneheart. You can see how large the Tyche Basin is compared to. We have the outline of north and parts of West and East and Central Africa in here. We've got most of Europe and a large part of West Asia. So the basin is pretty significant. But the reason why I wanted it up is so I can check where the different elevation changes are after I go through and map, generally where the climate zones are. I'm going to start doing that faux satellite, the satellite kind of map like I did for Rukia, and then from there I'll hone in on those climate zones. And we also want our July here. So, is that July? No, we want January. Ooh. Unless if I click on the January one, and that's okay. All right, so the precipitation is going to be coming usually from northerly winds, but it's going to be, northwesterly largely. And yeah, so that will be good. Northwesterly winds. So when we're moving through, I don't really expect much in the way of. No, something else is on. Yeah, we don't need that. I don't really expect much in the way of aridity, largely because, again, most of the precipitation is going to be received in the. So yeah, most of the precipitation is going to be received in the winter. So, I can always refer back to that chart just to check. But in this case, we're really not going to have a situation where we have so little precipitation that we end up in BSK. I think the one area that could happen is maybe got hidden layers. Maybe in here, like maybe there could be a little bit of BSK just because we've got that going on, or if there is some winds. Let me see again. Yeah, I mean even this is coming that, so yeah, I don't really. I mean maybe in here a little bit, but otherwise I don't imagine seeing bee environment in the interior here, just because we would have to. I can bring it back up again. Like, let's very quickly. Let's just check what the. Let's turn this outline off because I can get in the way here. so here, for example, is what, 17, 16 degrees. It doesn't need to be exact. And in July, it's kind of in the 22 zone, I suppose. I mean, it's a little elevated, so maybe we can say 21. So if it's, let's say 16, just to be fair. If it is 16 in the, or I mean 17 would be, so it's, the average would be 19 degrees, maybe? I think it's 19. If we take, 21 and 17, I think it'd be 16. So, 19, 18 degree average for that. So if we share our, where'd that go? Okay, we are having a bit of an issue here. Share screen. Okay, it wanted to share my StreamYard screen. That is not very helpful. Let's stop that. Go here. Share screen. Share screen. There we go. All right, so if we go back here and we have 19 degrees, which is between this dotted line and the 20, we would need less than 400 millimeters in that zone in order to get a BSH or a BSK climate. Looks to be about 300, less than 300. So if that ends up happening, then that's what we'll do. I'll make a note of that on a different slide. Which one was that? Oh yeah, that was some of the current stuff. Let's make it blue. Whoop, now that's much too big. There we go. And 300 will probably be what I'm considering for along here as well, to be honest. But I don't think that's going to happen. That's very unlikely. So we want this group to be here. We want this to be in the group, because we are going to do a clipping mask. There, great. Why is my opacity not on for that? Yeah. Oh, I did it for that too. Great, 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 great. Oh, it's just frogging? Oh no. What is frogging? If frogging is me being indecisive, then yes. That I can definitely control. Oh, it's on your end. Okay, okay. All right, so generally, let's just carve in yeah, great. So generally then, the stuff on the west of that line is going to most likely be CSA, and we're going to be doing that for... I'm going to fill in the stuff for the sea surface temperature first, and then we are going to go in and do... Yeah, and then we're going to go in and do the higher elevations as we, work that sort of stuff out. With deft precision, just filling all this stuff in. At some point, that's going to switch to CF, so, I'm a big fan of those little islands all over the place that we added. Oh, those are all going to be that too. Some of those are probably going to be CF, so I won't go too crazy. Mm-hmm. Sound is okay. Okay, great. Thank you so much. Everything's going Writers 2 end. Horizon's just having some little issues on there. Okay. So you can just kind of see how far I want to spread the... Yeah, it's probably good. Because this, I mean, the winds are going to come parallel, so I don't see too much. What did I do last time? That's a very good question. Yes, okay. All right, so now that we have broadly, and like, oh, yeah, but I now have the clipping mask, so that becomes incredibly easy. I don't have to spend my time going through each one separately. But I do have to make sure I don't miss them. Thank you for the reminder. We do have to color in all our islands. But a bunch of them are also going to be CSA, so I can come back to those later. Oh, this little island is not going to be. That's going to be a CSA island too, probably. All right. So we can also make that one a clipping mask. Rename. CSA. I don't have that color at the moment, so we are just going to make one. Okay. Now, maybe a little too saturated. But that's okay. We can always just change the color later. It's not that big a deal. And for this one, I am not going to be concerned with seeing that. I want to see the January. Ah! This is 18 line for January. So that would not be CSA. Good to know. Because if it is 18 degrees, if you have no monthly average temperature below 18 degrees, then you've got in a tropical climate. So that is going to be another AS region. This is nice though. I wasn't, when I was originally going through, I didn't really anticipate the CS regions, but that's also because I didn't really focus on the surface currents of, yeah, I didn't really focus on the surface currents. It wasn't something I was too interested in. No, the surface currents for the Tyche. I wasn't too interested in how that was going to pan out. Because again, it's not a part of like the global ocean circulation. It is a marginal sea, like, you know, the Black Sea or the Mediterranean, uh, or, you know, like the Bay of Bengal or something like that. Like there is a slight influence on temperature when you have it on these borders between, you know, 23 to 21 degrees, then that is significant for Köppen because of the difference between a CA and a CB, or a DA and a DB climate, which is, you know, that 22-degree summer. That's really important. And then, yeah, I guess if you were in a situation where, you know, the 0-degree isotherm was being moved slightly, that would also be something of interest because that would separate a mesothermal from a microthermal, so a C from a D climate, you know. And of course, a bunch of this stuff CSA is going to be CFB because of changes in elevation. Yeah, yeah. Boop. Let's add on, where possible, I would like to just snatch the colors and use them. All right, and how is it going along these ones? That would be, huh. And then where does that 18 in July end? Oh, January. Oh, okay. There we go. So then, great. Oh. But in the end, you know, especially in these larger ones, I don't think it's going to make all that much a difference. Okay, so January now. July. And that spreads all the way up there, so we will have, and July, yeah, so we're probably going to end. Wait a minute, what's going on here? Oh, I'm using the eraser. Oh. Okay. Yeah. Always check your eraser. Yeah. Otherwise, it'd be tropical. That's okay. There we go. Well, that's nice. Yeah, my thoughts exactly. So that's largely what I wanted. We got that in there. Yeah, just focusing on the stuff in here. Because soon we get to do our elevation math, so that'll be fun. Oh, okay. For that bit there. Yes. All right. CSA it is. Again, I'll hone it in once we get close. So we're going to stop for 1 sec, and very importantly, we are going to worship the sun. He needs to be much more visible for us. There we go. That's nice. Wait, what happened? Wasn't paying attention. I'm just gonna step away for a sec to refill my water, and then I will be right back. And we are going to start doing the temperature stuff. But right now, we are going to worship Mr. Smiley Sun. Test, test, 1, 2. We are back. Indeed. Oh, yeah, and Smiley Sun we trust indeed. What happened? You were not paying attention. I think I just forgot. I just forgot to make something CSA that should have been CSA. I mean, this is an iterative process. I'm going to be going back and forth, and sometimes I may miss a spot. I mean, there are certain parts in here I noticed I did not fill in on the outline, and that's something I kept note of that I want to go back and fill in here. Oh no, not lip noise. One sec. Welcome back. Thank you very much. You threw a party while I was gone. Oh, of course you did, for the sun. Yeah, every Sunday we have a sun party. For the sun gives us our insolation and also gives us our precipitation. The sun is very important to our world building processes. We would be worshiping the sun more often. Once I get to conlanging, we will have a con for the star that Otab orbits. But for now, it's just the dove's sun, I suppose. And the layers, you can see how exact I'm being with these. Because it doesn't matter. As long as it fits in the clipping mask, it's fine. It's fine. It's fine. All right, so what I said we were going to be doing before I stepped away for a sec is looking at the elevation changes and then calculating how that is going to impact our climates. I'm also going to be looking a little bit at how large these different basins are. I have key plates opened up on one of the laptops around me, just to see how far these are from one another, though I am not terribly concerned with the distance, and I can explain why. So, if we're imagining like these gaps here, oh, keep in mind my layers. Where's a good layer to do this on? Yeah, let's do it on that layer, sure. Hope the sun gods of this world are very happy. Well, they should be. There will definitely be a sun religion. There has to be one now. Though, I don't know. I'm always hesitant with the sun religions because, you know, then the sacrifice stuff might leak in. But I mean, you know, so many people do it. It can't be wrong. So if we think of the Red Sea, for example, you know, on the Red Sea, you've got, I think, 350 kilometers. Yeah, I think it's 350 kilometers wide. I mean, the Adriatic is also relatively like a, you know, short body of water. However, the Red Sea and the places around the Red Sea, if we take, for example, like Mecca, receives, I believe, around 100 millimeters of precipitation a year. And if we think back to those charts, that is going to place you as an arid climate, especially for how warm it is around the Red Sea. So, you know, normally when you think of these very skinny bodies of water, these very small bodies of water, you're thinking, well, there's not going to be very much precipitation coming off those. However, the Red Sea is often in that high pressure zone. So the high pressure is what is like, it's not causing winds, particularly cool winds, to move over the surface that would then precipitate on, you know, the coasts around the Red Sea. But we do have a lot of examples of lake effect, and, you know, when it's over a saline body of water, it's called an ocean effect. precipitation. There are some examples of this we can look at in the, you know, Mediterranean, for example. I think the northern shore of Cyprus is a good example of this because there isn't that much of a basin between the northern shore of Cyprus and the Anatolian Peninsula. And a lot of the winds come from the south. So they come from the south, they hit the reasonable mountain range. I think, on average, it's like 150 meters in elevation. Some of them are like, 2,000 meters, that sort of thing. And then in the interior of Cyprus, I believe it's hot semi-arid climates, like a BSH. Then you've got a very shallow, no, not shallow, a very, not a very tall mountain range that averages about, maybe 500 to 1,000 meters. And then on the north shore of Cyprus, you have very relatively arid, but still receives like 500 millimeters of precipitation. And that's from, the winds coming across the basin there. And that's a very small, quote unquote, fetch, right? I was sharing this with Edgar when he was doing the precipitation for Kretok, and we were talking about precipitation, especially in the eastern part. Oh shoot, I forgot all the names now. Janner, I think. Eastern part of Janner. Is the very large continent that has that interior basin that kind of looks like that like inland sea that kind of looks like a beak. And so when we're thinking about precipitation, a lot of the mass majority of precipitation on Earth originates from ocean basins. However, we do see significant precipitation from large lakes and marginal seas. An example of that is like right near me. So I can bring up a map actually. Let me do that. Let me just I'll just go to Wikipedia. This is not going to be where is it? Oh, found it. I know you can see what I'm doing yet. I just need to get to the page before I share my screen. Share screen. Allow. Remove from stage, add to stage. Excellent. You should all be able to see Port Angeles, Washington. So if we look where Port Angeles, Washington is on this map here, it is on the northern side of the Olympic Peninsula. So this is the Olympic Peninsula. It's got a bunch of mountains in here, and it is in the rain shadow of the Olympics. So the precipitation is westerly, southwesterly winds are coming in. They're hitting the Olympic Peninsula, and this area does not receive much precipitation from the Pacific. However, you may note that there is this marginal sea here. This is known as the Salish Sea, and you've got a bunch of different straits. This is the Juan de Fuca Strait here. So the maritime bodies of moisture that hit the Olympics here don't bring that much precipitation to Port Angeles, and those are usually throughout the summer. But you have cold continental air masses coming in from the interior of the continent. Those cross over the Salish Sea and the Juan de Fuca Strait, and they create a lot of precipitation in the winter. We've got winter precipitation here coming from two things. One of them is lee cyclogenesis, which is when the Leeward side of the mountain is bringing air in, and we were talking about that last time. We also have the cold air masses moving across the Juan de Fuca Strait and the Salish Sea more broadly and precipitating on this northern coast. And the reason why these very cold continental air masses are important is because when you have in the atmosphere, you know, far above sea level, lower temperatures compared to the sea level itself, you're going to create a lot of instability, and that can create a lot of like squalls. Yeah, it can create a lot of squalls. So due to the wind shear and the difference in temperature between the sea surface temperature and the temperature in the lower atmosphere. And what this does, there should be a climate thing here. Okay, and when you come here and you look at these and they say it's like CSB or something like that, I have looked at many of these and I don't know, maybe 20% of the time they're wrong. So don't always listen to what these Köppen ones say. So we have Fahrenheit. All right, here we go. Average precipitation. Look at this. So during the summer, when it's in the rain shadow, you've got very low, and this is April to September, so that's during the summer, quote unquote, summer. You've got very low amounts of precipitation, right? Like no than 150 millimeters. And the driest summer month here, July, 12 millimeters. The wettest month is in December, and that's at least 3 times the driest month. So we're definitely a CS climate due to the average of 9.2. It's a CSB climate because we don't have anything higher than 22 degrees, and we also don't have any months below 0 degrees. But here we can see that we have very clearly 600 millimeters in the winter coming from this, largely from the Salish Sea, right? From these winds that are coming over here and from the Lee cyclogenesis. So especially when we're dealing with CS climates in cooler regions, that this is something that can actually provide a decent amount of precipitation. Victoria is quite similar. The winds are moving. There are different patterns of pressure and wind movement, but when the winds move across here and they move across the Salish Sea, they are picking up moisture and then dumping them onto the South Island. There's islands over here. There's 2 mountain ranges. So as the air moves up, it cools more significantly and it drops more precipitation. And, Victoria and Port Angeles receive equal to more precipitation on an annual basis than London, England does, even though London is not in a rain shadow and, with Gulf Stream and all that jazz. Boom. So move that, and we're going to throw that. This is certainly an interesting place to live. Yeah. So I think that the Pacific Northwest is pretty cool. So when we're looking at this, while in a high pressure situation, which does happen during the summers, as we have talked about, here's the July, so see all that green, it's all high pressure. There isn't going to be much precipitation generated in these areas, right? But the winter, we have, where are we? In the winter, we have very cold masses of air moving off of the glacier, right? Off of the the Polonian ice sheet, these katabatic winds are going to be storming down from the heights of the Polomian ice dome. I believe the East Polomian ice dome is the higher one. They are going to be causing all sorts of fog and squalls as they move across. And, there's going to be a pretty significant difference between the cold katabatic winds that are coming off here and the, I believe, and so this is going to create a lot of ocean effect, quote unquote, precipitation and even snow and blizzards, especially because, when the precipitation begins to, when the condensation starts to happen up clouds, you're, going to get ice, you're going to get snow. It's going to pass through different layers of the air column, and you could get snow pretty frequently in the winter here, just because of that. Especially because, what about, yeah, the average in January between 12 and 18 degrees, you'll probably see a lot of snow up here for sure. You'd see snow regularly along there. And of course, we're also going to be looking at the elevation differences. So along here, for example, let's bring up the elevation. Boop. And this I can check very quickly in G-plates. I've got G-plates up in a different thing with the measurement tool open. That's like 150 kilometers. That's more than enough. Like, I think 100 is good for a fetch, just like as a rule of thumb. 100 kilometers is kind of a minimum that you want. But, the Juan de Fuca Strait between the South Island and the Clallam County, where Port Angeles is like, I don't know, 16, 20 kilometers. Yeah, it's not terribly much. So yeah, 130 points. This is, I think along here it's almost 200 kilometers. So we are certainly fine. And something to note as well is that we have this range of mountains here, right? And these mountains are produced in part from the rifting from separating these two areas, so that's a fun time. But what happens here is we have the Lee cyclogenesis that can pull in moisture because the winds are moving pretty much straight over them. So rather than seeing a rain shadow, I mean, the rain shadow effect would be true from the precipitation over here, but it's going to be drawing in moisture from there. So that will be useful. Similar thing here, right? Like along here, it's not going to, it's going to be in the rain shadow of these two ranges. So this area is not going to receive any precipitation from the Agathie or from the north or western parts of the Tyche, but it is going to pull in moisture from the body of water that's just to the east of it. And it's not going to be a significant amount of precipitation. I'm thinking around 500, 550 millimeters. Like, that's not that much considering the dynamics we have here. I mean, that's less than, it's around the same. Oh yeah, Cyprus, I was mentioning earlier, like the northern and southern shores of Cyprus. But if it's a CSA region, that's enough for it to be CSA and receive that precipitation. Something else we'll note too is that while the coast here may receive 550 milliliters, up in the mountains there's going to be about 1,000 millimeters, just because as it cools, that body of air is going to condense. More precipitation is going to occur. So that's why I don't think this is going to be particularly arid, even though I believe there was someone in the comments of one video who thought there should be a lot more aridity. Uh, the one place where that, and that's why here that 300 millimeter mark is up. I do think you could see some aridity because you got the rain shadow here, right? But if you have the winds moving off here, you know, you're gonna have a decent amount of precipitation. I mean, we could probably see just like some BSK in there, but like the situation is that this is going to be colder, right? Because we said at sea level there's that 19 degrees as an average, right? We have the mean there. So basically, this is a huge Aegean region that eats of Mr. Yes, it is. It is a huge, like, mega Aegean. And of course, you know, all of these land masses are much larger. Like, I believe, like, if we're looking here, like, this is the Aegean. So, you know, a similar area, probably like in here or in there, I guess, if we're just thinking about, you know, a bunch of little islands all crammed together. But it is like a mega Mediterranean. And the whole point of having this mega Mediterranean was to help alleviate some of the impacts that A, having a supercontinent can cause on aridity, and B, the decrease in precipitation from having lower annual average temperatures just globally, right? Because you're going to see less precipitation because of that. What was I saying? Right. So 19 degrees Celsius at surface at sea level, or two meters above sea level. But up here, we're already, what was that? Half, I believe. So this is almost 1 kilometer. The 1 kilometer, and then these yellow ones are 1 to 2 kilometers. So that, yeah, so this would be, this is 0.5 to 1 kilometer, and then this area is 0.25 to 0.5. So since on average, for every kilometer, we are going, for every kilometer of elevation, usually it is a 6.5 degrees Celsius decrease in temperature. So up here, this would already be less than 18 degrees along this line here. And then along that line, we would be looking at 15 degrees. That's before we get to here, and it would be 13 degrees, right? So this 300 number doesn't need to, you know, hit the 19 degree mark, which, you know, you want to go back at some point to the slides and, you know, make those comparisons. There's an equation that you can do. I just made it, you know, I just have a chart from, you know, different lecture that I'm, you know, doing because I find it to be easier than doing the equations on stream. So if you have 300 millimeters of precipitation and your average is now 13, or yeah, so for 300 you need to have a temperature higher than about 14.5. So maybe we have some BSK on the leeward side of that ridge But that would be no. But we can't. It would have to be along here. It can't be along this because that is that would be that would still be receiving some precipitation from the elevation. So it would have to be in here if we're going to have any ESK. It would be in that region there. Essentially. Yeah. All right. So let me get this out of the way so I can see if there are any comments. No new comments. Okay. So have some hydration. Oh, yeah, and just a reminder for folks, do have the Patreon has put up another month update, January 2026 update. I think when I put the December update up, I dated it December 2024, which shows which year I'm living in. But I made it now. I updated it so it says December 2025. The Yeah, and for the January 2026, talked about the schedule a little bit, and then introduced another sneak peek at one of the creatures that we are going to be seeing in the Chapter 2A, the Wet Winter, Dry Summer ecoregion video, which, yeah, should be done by the end of January, probably released first week of February. And you can also sign up for free to the Patreon. You don't have to have a paid membership. You can have a free membership. For the free membership, you'll get I think you can get an email for all of the updates for like live streams and stuff like that. And I think you can still go in and check to see when I post the explorable Patreon for like seeing a video the week in advance. That way you'll know like when it's going to come out, more or less. What do you want us to comment on? I don't know if I asked on comments. The possibility of tiny D areas? Not in here because in the, let me see here. Yeah, I don't think there's a possibility of tiny D areas inside the basin, especially like this area, because they're not, I don't think they get cold enough to go below 0. And if they do get cold enough to go below 0, I believe they're also cold enough in the summer to go below 10 degrees, in which case they would just become E climates. So I seem to want more comments. Oh, no. I was just, I was just saying people can sign up for free on the Patreon if they want to see lives and stuff like that. People can also make comments. That's great. Like, comment, subscribe, and hype. Apparently, people can hype things now. I don't know what the hype is. I don't know what hype does. YouTube just keeps adding things people to ask their commenters to do. But like, yeah, we can look at the possibility D areas. I mean, the D areas are going to be all up in here. Oops. D area is going to be up in here and along there, right? Like this is going to be D areas. Acoustically hyping, wonderful. A hype, yeah. If I can scream it later. I think hyping is similar to the hyping on Twitch. See, I don't use Twitch, so I have no idea. someone can clarify then. All right, so let's see the lowest temperatures that we can get here. Let's turn that off for a moment. Oh my goodness, let's turn that off too. So if we are July temp and we're there. So if we have July here, and that means it is what, 19 degrees in the summer, and that means, yeah, it is, that's color in the middle, 9 degrees. Wow, that's pretty big sweep. So then the average is 14, which is fine. Yeah, not going to be arid at all, but there would need to be 1.5 kilometers would bring it down to 0, and it would bring the other one down to 10. Yeah, so anything along here, that any mountain that would be tall enough would create an ET zone rather than a microthermal D climate. Let's see here. Yeah, and I think we may not have the same situation along there. Let's check there. Let's say, yeah, it's probably also around 19.5. That's 22 here. 22, 21, 20, 19, 18. Okay, yeah, 19.20 here. And then at sea level, 18, 17, 16, 15, 14, 13. Sure. Then we can throw down this thing. So this is 1 to 2. So if we assume 2, then that would be 1 degree Celsius, about 1 degree Celsius, or just slightly above 0. And then this would be reduced down like 12, 13. Yeah, so then that would be, yeah, we just get ET climates. So yeah, we just get ET climates. There's no, like, in order to get a D climate, you really need to have that kind of like continental swing in temperatures, right? If we think about the continentality and we're looking at the ranges at different latitudes. So this this dot is along here. It is, you know, at, I believe, 30, what is this? Okay, that's the 30 degree line. So that's 35 degrees latitude. So at a 35 degree latitude for an oceanic continentality, you're just not going to get the swings necessary for it to become a D climate. Zalea here, around here, it's a bit different because you do get, you know, the more continental. Yeah, it does get more continental along here. It's more continental and into here. So this is where our Ds are going to be, not in the basin. Oops, bumped into my microphone. Aw, thank you so much. Thanks so much, Jake. Yeah, I have. I'm really enjoying incorporating my art into it, and I'm certainly getting better at it. I think folks are going to be excited at the critters that I've got going on. Everyone's seen the Dovian, or the Urukian more specifically, monotrematiforms. I've also got an entirely separate group of animals that are going to be introduced as well that haven't been shared on the Patreon or on any of the streams before, because I know that people would have seen the Kapal, the monotraumatic horse from the chariot one, and then the only ones that have been revealed in the Patreon updates have also been monotraumatic forms. But there's an entire group of animals that has not been introduced that I think will be pretty exciting, and I'm pretty happy with it. I've only been consistently drawing and digitally painting for, I don't know, like eight months now. So and I do see improvement. I am definitely better, especially drawing different animals after paying attention to the skeletons and stuff. So I'm really excited, and thank you, Jake. Yeah, we're going to see more artwork for sure. I'm daunted about doing more of the Dovians because I think my first attempt for the chariot video was fine, but I'm definitely studying more to get better at drawing people. All right, so from here, let's do one of those climate tests for the temperature tests for the sea region. So we've got our January temperature. So again, 18, it was over here. 17, 16, 15, 14, 13, 12, 17, 16. Yeah, okay. Maybe that 14 is a bit too close. But again, there's always going to be like microclimate and variability and those sorts of things. We can also see where there's also going to be a difference in the surface movement of the different climates. So this do believe that the winter sees a change. So when I go back and do the thermal, what is it? Yeah, so after I finish doing the climate study, I'll probably go back to the thermal map and push this, push this down a bit more. So, bring down the 6 degree isotherm and then bring that down a bit. So we'll probably see a slight change, but I don't impact over here all that much, which is but I did kind of compact these a bit more just because this would be moved down. But even though there is a reversal in the surface winds here, there is a reversal of the surface current because the surface winds change. The subsurface current is still the same as it is in summer, right? Like this winter change is, only really impactful for a few months of the year. Oh, writer 2. Okay. On Twitch, you pay money to create a hype train, giving a streamer a decent sum of money and the stream watchers emotes and stuff. Huh. That's interesting. Yeah, I don't know. Like, whenever I like a video, it's like you can hype a video as a new creator. It's like, oh, okay. But I don't know what it does. And I don't think I've been hyped. So I'm gonna, I guess, read one of the YouTube thingies and figure out what that is. Okay. So 16 there in the 16 there in the summer. Was that in the summer or the winter? Oh, it's in the winter. Wonderful. And then we've got, yeah, so in the 22 in the summer. Right. So based on that, I decrease it by Yeah, so if I decrease it by the 2 kilometers, then we'd get around 10, 9.5, 9, 10, something in that range. And if we decrease it by 2 kilometers from the 16, again, 3 to 4. But what we need to figure out might push the video in the algorithm. Yeah, maybe. Possibly. I must wonder why they'd have that and the promote feature though. I have no idea. Just trying to get people. They keep adding things, it feels, and I could be well, I'm still kind of ambivalent about it and apathetic towards it, but as someone who just watched YouTube videos, I was certainly apathetic towards it. But now, as someone who's making the videos, I'm just kind of ambivalent. So that is at 2 kilometers. But what I want to know is when it would hit that 13 degrees, because that's when it's going to become CSC. And that one is the fun one that's going to add a bit more variability. So yeah, it's probably around the 500 mark, eh? Oh, in the winter. Yeah, I don't really care about the winter. I care about the summer. So in the summer, probably 1.7. Because it's 1.5, that'd be 9. Yeah, about 1.5. Okay, good to know. Oh yeah, but at a certain point it becomes a CB climate. When would it become a CB climate? Probably at the 2.5 mark, it's going to become a CB climate. Okay, so let's go back to this. Okay. And yeah, then the 1.5, it is going to become a CSC. So I'm going to create that layer on top of this one. I'm going to clip it. We are going to rename it. We are going to just open that up very briefly. Grab that. Let's go to the studio pen because that is a bit easier to control. And now this one is going to happen at, what was it? Like the 1.5 mark. So it's going to be in the interior of these mountains. Where was I drawing? See, this is what happens when you're not keeping track of your layers. All right. You know what? It's probably going to be there anyway. But let's just do it here. Let's turn off the brown layer for a sec. That's true. I also need to do it along there. Ah, that's true. I'm doing it along here. I'm not doing it. With all the climate stuff, I tend to eyeball it instead of going to realism. Generally say it's better if it looks right instead of being right. Well, we can do both. It can look right and be right. Thank you. And also, people are interested in different parts of the process. I mean, you don't need to go through all this jazz in order to end up with climates that, look nice and reasonable. And so, let's look at the difference there. Yeah, neat. And going to be any, significant areas of ET in this region. I mean, probably get some. Maybe we'll have like a little peak there of ET, but, I may just throw it in. Yeah, sure. That's too big. That pixel's too large. Yeah, that seems fine. But, yeah, this is what happens when you do have these like very, moderate oceanic basins. You're going to need some pretty significant changes in elevation in order to get those ET climates if you want them. And then we're going to have a similar situation along there, though that is just, that doesn't get higher than a kilometer. And I tend to think with the climate stuff as well, you being inspired by interesting features, like what I was talking about with like the, lake and, ocean effect precipitation and, how that impacts column territory on the north side of the Olympic Mountains in the, the Salish Sea area, right? Like that can provide you with information for, you know, how to make things differently, right? Like, because if you just go through the process, uh, you know, I don't know, at a very superficial level, and you're like, oh, on the, leeward side of some mountains, there's going to be a rain shadow, so there's not going to be any precipitation there. Or if you're thinking, oh, all precipitation originates from, you know, ocean basins, right? And if it's 2,000 kilometers away from an ocean, you're not going to have any precipitation there. That you're going to end up with some, I think, you know, you're going to end up with a climate map that has a degree of verisimilitude, but there are going to be things that some look at it and be like, well, that doesn't, you know, that may not work. And in which case, you know, I think the sort of heuristic or the vibe based method could work. Where you're like, well, especially if you're working with like an Earth analog, right? And you're doing an analog for something that we actually have normals for. Like if you're doing 14 degrees, we have normal. Normal is, I think, usually like 20, no, 30 degrees, 30 years. A normal is a 30-year period that average precipitation and temperature data is taken from on a monthly basis to come up with like Köppen and Tuatha maps and stuff like that. And you know, if we already have those maps, then sure, like you can easily just kind of look at it and do what feels right. I think that for a lot of people may be a lot easier than going through these other processes, and you can end up with some pretty good results. Though where it starts to fall flat is when you start building worlds that don't resemble any of Earth's like configuration of land masses, and you're like, well, you know, there isn't an analog that you can sort of heuristically draw on. And I think that's where, you know, this process can be more useful. And you don't have to go into detail with it as much as I do, certainly. Um, but, you know, occasionally you may need to do that. Yeah, and some of these are pretty sharp. And this is only the first step that I usually do, right? Like I'm, you know, just kind of sweeping it in on a local level and then at sea level. And then I go in and see, you know, based on, well, that's because that is not black enough. There we go. And then I go in for the elevation and start adding stuff in. Even then, though, I think a lot of this is just going to be CSB with some CSC ridges and stuff, like moving through it. It's not going to be. I think what adds the visual interest is more so the terrains and the islands than the climates themselves in this case. Also, not jinxing myself, you know. Praise on. We have no audio problems. I haven't had any visual problems. I haven't accidentally removed myself and lost audio. So we're doing. I'm doing pretty good. Oh, you get what I'm saying? But the problem is that you're a deep dive world builder. If you get too invested in this part of world building, you're gonna get seriously stuck in it. I can appreciate that. I have some projects where I worked on just the climate mapping, like the physical geography stuff for, I don't know, like a dozen years, 12 years. My like personal main project. I've, you know, working on the physical geography for a really long time. I went through several iterations of it. Um, I was also building other stuff alongside it, like building cars and doing conlangs and those sorts of things. But yeah, I can totally see what you mean, especially if you want to use something. Like I was doing Hade because I wanted to do it. Hade, doesn't matter. Um, I wasn't planning on writing anything in it. Like I did write some short stories and stuff like that, but that wasn't the goal. The goal was to just do the world building thing. And I don't want getting stuck in the weeds. Which is also, you know, why I'm doing this stuff on streams, right? Like I have a very specific time I get to work on it every week, which is quite fun. Oh, That's lip noise, sorry. So, looking at our elevations here now, we can move a bit further north. Let's flip on that layer while I was counting the temperature. Okay, so how are we doing here? Yeah, so that can be 15 here. And this is in July, it's 15. No, it's not. That is the winter temperature. So the winter temperature is 15, and the July temperature is closer to 21. So if I introduce a kilometer of change, that would be, it would still be a CSB climate. Yeah. So if we have 2 kilometers, then it would be ET. What would we need for it to be? Yeah, I guess, again, 1.5 kilometers. No, yeah, just under 1.5 kilometers in order for it to change to a CSC climate. And does that turn yellow? Nope, no it does not. All right. And also we think about our precipitation here. Again, I don't think there's going to be any major precipitation changes, because going over here, we do have this ridge here, which would catch some rain, but it's not going to be a significant amount. And if we start over here with like 800, 900 millimeters, you know, we could easily end up with 500 over there, 600, which is what we need, considering it is only, bring up my G plates on the main computer again. So if we start at here, though, you know, we would get precipitation from these a little bit. We get a little bit of a boost. But if we do start from over there, and then follow this movement, that is 500 kilometers. Like, that's not a significant distance. So we're still going to have a good amount of precipitation, especially because we got a little, you know, we got a lake there. Especially because we got, you know, that lake effect, right? And that little lake is, well, it's not, that is a bay. And the bay is here at least 100, over 100 kilometers across. So lots of precipitation, nothing to worry about. And looking at it on GPS here, I can see that there are no yellow pixels. So we have nothing to worry about. Kate, yeah, I'm into world building, quad world building. Yeah, that's, you know, why I'm into it. I mean, I may do some microfiction, you know, the world building has gotten me to draw a bunch of stuff. So, you know, there's other art endeavors that come from it. But I do just enjoy the process. I am so into the physical geography that I just, you know, do it for the joy of the physical geography. There isn't enough geography on Earth to make more geography. So this area, as a base, is pretty well done. I do want to move up here. That place is also pretty much done. I don't believe there is any significant elevation that would change it. Though, I do get some going up to a kilometer here, and I do want to double check what the... do want to double check the temperatures here. So that is July, 18 there. So yes, 19 we mentioned, or 18.5. That's not a good color for that. That's a bad color. Okay. 18.5. And 9. So we do have some stuff that could go up to a kilometer, which would be 3 and... Nope. I can't add. Oh, that'd be 11. If I just take it kind of straight up. 2.5. Yeah, 2.5 and 11 if I took it straight up. The other thing is with elevation. Yeah, with elevation and the change of surface temperature is also depending on how much moisture is in the air. So moist air masses would decrease in temperature less with elevation. Drier air masses, which tend to be, tend to be colder because colder air masses carry less moisture, tend to cool quicker. However, in this situation, are cool air masses that are very humid, right? So sometimes you have to split the difference, which is why the average can work pretty well. But like, if we're talking about an ice dome, or if we're talking about a very tall mountain like Everest, it cools a lot quicker at altitude than 6.5 kilometers. Than 6.5 degrees Celsius per kilometer. Excuse me. Oh, you need to get into geofiction, but you're in a conlanging rabbit hole. Hey, conlanging is a fun rabbit hole to be in. And, it can be nice to work on something else for a bit, to like jump around. So yeah, we would probably hit that 13 to 12 degree mark, which would give us a CFC climate, not a D climate. I know we're looking out for those, but that'll probably be in a few streams. I may do some of the D area. I may do a D area next stream, because I do want to get a base sketch of the climates down, and then do the satellite, and then go back in and refine everything based on the satellite paint that I do, because I did enjoy that process for Rukia. Okay. So I have a couple places along here where we'll see this happen. So let's turn that off. Oh, excuse me. Okay. Got that in there. And then we've got this in here. Brilliant. And I believe there's a little bit here that we could get those on. Though I do want to double check that because that's further south. Uh-oh. Okay, yep, that would not be there. Nice. So for this one, let's open up this layer again. Yeah, 13, sure. Oops. And it's probably going to be 19, isn't it? Oh. Honestly, maybe closer to 20. What did I say down here? 21. Yeah, sure. 20. So if we bring it down by 1 kilometer, then we would get 13.5 and 2.5. No, no, we would not. Yeah, struggle bus over here. All right. 6.5. Great. So yeah, I'm going to take it off of this southern one. You know what? No, it is an average. I do like it, though. I do like it looking like this. I'll keep it. It'll be fine. It's close enough. It's very cold up here, especially in the winter. But it is the summer time. It is the summer. Well, the air is dry in the summer. The air is dry in the summer, so it would cool quicker. So that's fine. We'll just say in the summer, the air is dry, so it is cooler. Therefore, we can have our CFC climate up there. And see, if you know that, then you can justify it. That's the you can have a reason. I think Jake was telling me that recently for some conlanging stuff. You know, that's what David says, right? It's like, okay, well, if you have a reason for it, it can be a cool feature. Otherwise, you know, does it usually happen that way? You know, you need to think about those things. And that's sort of a natural thing for me to think about with doing the physical world building stuff and the conlang stuff that I'm more familiar with. But I do want to include register tone in one of the conlangs for the groups that are in Aruba. So, you know, need to think more about tone and how the tonogenesis and things happen to justify some of the things I want. And I think in that process, the language that I originally thought would be a quote-unquote proto-lang is more likely not to be a proto-lang, is more likely to be one of the ones that comes after. Because in the proto-lang, I'm going to justify and figure out how those tones emerge. Could have some variation where, you know, tones emerge, and then in one of the languages, that tonogenesis provokes, or whatever, high tones, and then the other one it does low tones, which is something we see in languages in the Pacific Northwest, where glotalization created register tones, but in some languages, that glotalization produced high tones, and in others it produced low tones. So I may take that, I may use a different mechanism in order to provoke that, but we'll see. So we did this top one. What time is it? Yeah. I'll take a brief step away, and then I'll come back and we'll go for another 20 minutes or so. I'll hail the sun while I'm gone. And we are back. Boom. Yeah, go for another 20 minutes or so. So what are we going to tackle? I mean, we can move on to this big terrain here. And I was thinking, what were the names I was thinking for these? I have them in my notes. One sec. Yeah, I think the large one I wanted to call the Peristeronian terrain. And that was, that placeholder name. These are all placeholder names. This is not, yeah. I think that one is from the Greek, Peristeroni. So the Peristeronian terrain is this big one in the middle here. Then this failed sort of terrain, well, not failed terrain, but the failed microcontinent. It's not totally its own separate thing. Up here, I was thinking of calling the Kenian terrain. And these islands in this terrain here, I was thinking of calling the, what was it? The Barumbarian terrain. If anyone figures out where all of these, what the inspiration, I guess, for all of these placeholders are, that'd be fun to hear, because I haven't seen anyone suggest anything yet. Okay, so I did have this snake down, the CSC snake down into here. So let's go through that process. July temp. It is well within what we are saying is the 22, I believe. Yeah. So we're going to say that one is 24. At the tip here. And what was that in the winter? Probably looking like 19 in the winter, in all honesty. All right, so that 2-degree drop will probably happen at that 250 mark. 250 meters. Yeah. Bring it to like what, 21? No. Closer. Yeah, we want the 500 meter mark. 500 meter mark, probably bring it to 21, so around there it'll become CSA. No. Because we have to look at the CSA will trigger because of this. And it's 19, that's going to be triggered quite quickly by elevation. So there's going to be a CSA interior here. So then this drops to 18. This would be 23. And yeah, so that's going to happen with, we can call it 250, but I want to move it in from the 250 meter mark. And then the next significant drop will be to CSB, which will then happen at that 500 meter mark. Yeah, with 21 and 16. And then 1 kilometer, we would hit 18 and 13, which is still CSB. And at 2 kilometers at the tip here, we are heading down to 12 and 7. Right, so in the south, the lowest we're going to get is CSC at 2 kilometers. So let's add our CSA here. Just make sure I'm on the right layer because I don't want that to happen again. Okay. Mm. And it doesn't matter if it gets out of the 250 too much because, you know. Because the change in elevation that would cause it to go from the AS, the tropical wet winter, dry summer climate, to the, you know, CSA mesothermal climate is a very small one. Have a more gradual transition on both of these sides. It's the elevation change. There we go. All right, now we will go into CSB. And our CSB is going to be that 500 meter mark. And the 500 meter mark is that lime green. That's what we're interested in. Oh my goodness. I did not realize that it went that far. Okay. Okay. So that northern coast there is... Here we go. Okay, that's better. Those rough outlines look fine to me. And again, all we're looking for right now are those rough outlines. Okay, now that we've done the south, and this is just, again, the southernmost tip is what we're kind of going off. And now we can check for north and work our way down. It's a lot of, iteration and going back and forth for this stuff. Okay, so we're here. This is our winter. 17, yeah, 16, sure. And then for the summer, oh, that is another 22. Okay. And this is right on the transition, I believe, that I've already... Yeah, right near the transition. Okay. So we're going to have the CSB come out a lot sooner. And at that, yeah, 250, it'll already be CSB. The 500. Is that right? Yeah. And then at the 1 kilometer. Eh, 17.5-ish. Yeah, that's not interesting. That would still be CSB. Let's do 2 kilometers and see where we get. That would be 10. So that would be ET. So at the 2 kilometers, we get ET. When would we get that minus the 9 is 13. Yep, 1.5, we get CSC. And then at 2 kilometers, we get AT. Okay. And we will have more of that CSC. So let's spread the CSB first. Mm-hmm. What I suspected. Great. There we go. Just a little flare. Oh, see you later, Rider 2. When was that? Oh, it's a couple minutes ago. You can check it out later. Oh, it's nice seeing everyone for our weekly streams here. I hope other people are taking the time to get their own world building stuff done. So that's usually what I do. I haven't really been much of a stream person, but over time I've gone into the streaming, just, watching people do streams. I'm usually doing my own stuff. Idly paying attention. Okay, so 1.5. So the 1.5 is going to be kind of in the middle here. I'm doing it on the right layer, right? Yep. Great. We'll say that works for now. And then down here, it is at the 2 kilometer mark that it becomes CSC. So I want to resign that for kind of the middle of these. Not resign that, reserve that. And then, of course, I do want some ET. And 2 kilometers is ET around here, so let's... Yeah, that should be significant enough. If anything, it's too much. And you always want to make sure your ET, like when you're moving up in elevation for your climate zones, you always want to make sure that there's enough of the other zone around it, so it's not, left behind or anything like that. Like you wouldn't want to do something like that where you've got the CSB surrounding an ET zone because there's no transition. As well as quite nice places to chill and chat with people. Oh, that's good. Yeah, I think usually for these climate ones at least, we've had between a dozen and 12 people. Big ones don't appeal to you at all. Yeah, I don't know if these will ever become a big thing. They became... I mean, even when... what is it? Now that Edgar's still doing the streams and made them public so people can, join in and watch from the Discord, there's still only around 20 people. Yeah, I can imagine that they'd give folks a headache. I mean, I think I've been on some I've watched some Let's Have a Booba ones, a couple of Madeline's, some of Edgar's. What is it? David and Jesse's occasionally. But I think we'd call those ones bigger, right? Not that I pay too much attention to how big other streams are, but again, I don't do it very much. Yeah, that's not centered enough. What was I thinking? Yeah, it looks reasonable. I think some of this is a bit too pronounced. Yeah, it looks a bit better. Yeah, we are going to have these very thin straight teeth, but we're also that's not good. These areas are also going to be very these areas. Oops. Let's do the blue one. Let's throw the blue one on because it's the precipitation, so we already have that. The areas are going to be quite pluvial, right? Where we could imagine along here, that kind of 600 to 700 millimeters of precipitation. We're going to have along here about 500 millimeters of precipitation in these areas, easily 1,000 millimeters of precipitation. So a lot of people are actually going to live up there. And my original idea was to make those, I think I was discussing last week, where we'd have uh, garrigue, uh, which is like a, I don't know what the English term is, but like that's the French term. You've got this blend, essentially, like the shrubland with a lot of salt-tolerant plants near the coast. As you move in, you would have maki, and maki is like a evergreen shrubland that's pretty dense in the Mediterranean. And as you move up, uh, you're going to, just because of how cool it is, you're going to transition into more of, like I guess more of like an alpine or a montane shrubland where there's less shrubs. It's sparser, uh, and the shrubs, I guess, will be shorter. But that's more so because of the temperature and probably because of shallower soils. Um, because on the side of a mountain, you're going to tend to have shallower soils than you will um, further down, where different sediment starts to accumulate. Though, I mean, in valleys and stuff like that, you're going to have some deep soils. So I could imagine you'd have spots of like forest trees and stuff like that. Originally, though, I was thinking, like, oh, it'll just be like an alpine grassland. But besides the ET parts, where it is much too cold for many things to grow, um, you're going to have a decent amount of flora. Oh, what do we got here? They are bigger, but nothing like the ones you see on Twitch. Again, never been a Twitch person. And I grew a bit bigger, but you know more of them now. Yeah, that makes sense. Gaming streams, where there's game audio, and we're talking over it, and they're playing really fast-paced Pokemon battle music in the background. Oh, yeah, that's just too much stimulus, a lot of input. A bit bigger. Yeah, I gotcha. So there is there's going to be, and something that we're going to see in these CB and CSC regions up here actually is, I think yeah, and I'm thinking about Cyprus again, and I'm thinking about Lebanon and stuff like that, where you have the elevation and you have that precipitation. You're going to see, this world's equivalent of cedars and stuff like that growing, right? So even in, along the borders of these ET regions, you could have, some pretty substantial growth. Though, what is limiting me from including too much of that at the higher altitudes is definitely the lack of CO2. So, all of these things have to kind of balance out together, but we are going to see, some of the, there are going to be locations where you have some of these evergreen trees growing, but they're probably going to be in those river valleys uh, that are kind of up along these coasts. Up along these coasts. So rivers that come down along those river valleys at higher elevations, you can definitely find some decent trees. But, if and when there's a brief warming period on Dove, there may be a, concomitant rise in CO2 levels, and that may, precipitate a spread of some of that taller flora. Though sometimes you don't even need the CO2 increase to see trees spread outside of refugia, in the same way that cooler temperatures on their own and warmer temperatures on their own are also enough sometimes to inhibit or encourage the growth of certain flora. I think I'm not sure if I told this before. During the Dryas, younger Dryas period, we did see a brief increase in that kind of mammoth steppe kind of ecoregion in Eurasia. Even though we didn't see a huge drop in CO2, we really only saw the temperature drop. Though, there were different causes for those things, like yeah. But certainly during the last glacial maximum, and we tend to see uh, much longer sustained cold temperatures as CO2 drops. So we do see um, you know flora responding much more significantly to that. Okay, then the last thing I wanted to do a quick temperature check for was in this. Oh, I thought I opened that. This region here, just to see how much that this is going to spread. So if I do there, start that off. Ah, right behind the 22 again. So, yeah, okay. Essentially 22, I mean. Yeah, and 16. So it is the same as over here. So what do we got there? We got the quick drop to CSB, a very drop to CSB. Okay. That's interesting. So now, okay, because this is going to increase in elevation. I'm still on that layer, right? Yeah, it doesn't matter. So this is going to increase in elevation, but it's also getting warmer as we get closer to there. So if we do, so we may see it goes CSB then CSC again, which would be interesting. Okay, let's do the X there. Turn that off for a sec. We're not really thinking about elevation at this point. We're just doing the surface level. So that's the 22 mark. So yes, it's inside the 22 mark. Yeah. If this is like 23 down here. Yeah, 23.5, sure. No, yeah, no, 23. 23 is fine. So 22 here, 22.5. And that's the number we care about for the transition to CSB, but it's only going to take, yeah, 125, 250. That's only going to take 250 kilometers. Sorry, meters, 250 meters for that to switch. And I believe that's already within the 250 meter. Yes, so all of that's going to be CSB. Cool. And we want that. Oh yeah, okay. So that's a very shallow transition there. All right. And I don't like how sharp this is. So let's just erase. Let's just go. There. All right, so let's turn off all of our little layers here. All right, so far, just a recap of what we were able to get through this stream. I'll add on another layer here with the black so we can talk about it a little bit. So for the main terrains of the basin, we have added on the CS climates to a reasonable extent of where they're going to be. We can look at that later. We talked about precipitation, and I went over the thresholds for B climates where a majority of the precipitation occurs in the winter. And through talking about some, proxy locations, talked about Cyprus, talked about Port Angeles, I could also talk about like Dalmata and a couple of those places. You can receive, on average, like over 500 millimeters of precipitation, even from things like Lee cyclogenesis or from the lake effect, or in this case, ocean or sea effect precipitation, that ensure that we're not really going to have that much in the way of arid climates. The only place where we could have an arid climate is in this sort of region here, but one of the issues with that is that it tends to be a little cooler. So in those regions, it becomes even more difficult to have, in those regions, it becomes even more difficult to have a, BSK climate, because you have a further drop in temperature, which means you have to have less precipitation in order to have an arid climate there. Oh, sorry. Looking good. Thank you so much. Yeah, I think this looks pretty good, and we can also see a bit of a difference from this one, right? I think one of the main differences is that the CSC climates are not as pronounced. But that's also because when I was doing this, I was trying to communicate these sort of broad changes. I was trying to communicate those changes and maybe make some of these features a bit more pronounced. I also think maybe the colors aren't as different as I would like them to be. Yeah, that's pretty dark, isn't it? That CSB is darker than I would suspect. Are you gonna fill? Are we gonna get to fill? Come on. Ah. What is going on? All right, fill. This is frustrating. All right, come on. Ah, there we go. That is a lot better, I have to say. There we go. Now we can see the CSC climates more clearly. There we go. I don't know what was causing it not want to do that, but here we go. That may be too light now. Who's to say? Yeah, more in line. All right. So we've largely done... There we go. So we've largely done here. We have done this area. So next time we will continue. We'll look at the area in here, and we will look down there at those at the changes we see, because this little area will not stay AS, since we're going to have the CSA extend into it due to elevation. We're also going to have the CSB region extend through here. Probably going to have some CSC in there. Once we do that, we can, we may look at this area, but I think it may be more reasonable to actually start here and then move. Let's give some saturation there. There we go. Let's give some color. All right, so we're gonna start over here and then maybe move this way to fill everything in. I think that may be a reasonable path to take, kind of like a clockwise move through it. Hey, that should take a few streams. I'm sure the chapter 2A will come out, and after that, we'll figure something else to do, whether I do a close climate study of another region, or I find something else to do on Dove that we can kind of work through on the streams. Though, I do think doing a close climate study on Ilea would be interesting. Ilea being this region over here. Since after chapter 2, chapter 3 is going to talk about the early migration, which, you know, moves, I think, up to... Yeah, we're going to talk about the early migration period, which moves up to, I don't know, about 10,000 years before the so-called present time, which is where I'm planning on not going any further. And I think Alea will be interesting because we can explore very different kind of climate situation, right? Because here we're talking a lot about working through how this sort of Mediterranean system works. But over here in Leia, you know, we can spend some more time looking at the west coast of the continent. I mean, there is a little bit of a Mediterranean area in the north, though we can spend some more time talking about the tropical bits and talking more about monsoons and stuff like that. We've got more of Mr. Smiley Sun. Yeah, so that may be something to do next, at least until we're done more of the chapter 2 stuff, and then I'll probably transition more into focusing on, you know, developing some of the human stuff on the stream, maybe one of the conlangs. I'll take some time to develop. So, you know, we'll see what people's interests is in. I was also thinking on streams maybe of inviting, you know, Jake and Miles from Let's Have a Bond, talking a bit about their maps and the climates and stuff on there, seeing how that would work. That could be fun. But yeah. Anyway, thank you everyone for jumping on to our stream today. Just a reminder to share, give me a like and a comment. That really helps with the algorithm, and I enjoy answering questions. And if you have any questions, then I can, you know, and it's too much for a comment, I can talk about it on a later stream, or I can save it and use it in a later footnotes video. If you haven't subscribed already, I'd appreciate the subscribe. And I'll see you next week. Well, thank you for the stream. Well, thank you for joining. You know, I really appreciate that we've started to, you know, grow, you know, about a dozen people who jump on each time and comment and stuff. It's really enjoyable doing the streams where it's just talking to myself. Not a good time. So, you know, I'm glad we started to build that up together. Yes, I'm glad you could stay the whole time too today, Jake. All right, thank you to everyone, including those who had to leave early, like Ryder2. Thank you to patrons like Kate for jumping on. Really appreciate seeing everybody. And I will see you next week.